Hello wonderful person, this is Anton, and today we're going to be talking about what seems to be the most famous asteroid ever, the asteroid known as Apophis. This asteroid was trending back in 2004, it was also trending a few years ago, and now we've started talking about it yet again, because something else was discovered about it relatively recently. But let's actually learn a little bit more about this asteroid, and also discover if it does pose any danger to planet Earth. First of all, when we originally discovered Apophis back in 2004, the scientists thought that the collision chance with this asteroid, or the chances of it hitting planet Earth, were much higher than they are today. Back then the scientists believed the chance was about 1 in 30. But following extremely complex calculations and a lot of modeling, the scientists established that the chances are much lower, with the most recent analysis suggesting that in 2068 there might be about approximately 1 in 150,000 chance that it might hit planet Earth. Until 2068, the chance is practically zero. Although we're still going to talk about something else that was recently discovered. But first of all, it's also really important to talk about what exactly is Apophis, how big is it, and does it have any friends? Well, if you know Greek mythology, you probably know that Apophis was essentially the snake god of chaos. Chaos and destruction, to be more precise. And not surprisingly, this is one of the reasons the scientists gave it that name, because it was expected to cause a lot of chaos and destruction if it actually did hit planet Earth. But because of this initial scare back in 2004, for the past 16 years, there have been a lot of studies, a lot of analysis, and a lot of different models, all trying to figure out what, when, and how any of this might happen. So, for example, a lot of models actually try to simulate the potential chances of collision. A lot of models focused on if the collision happens, what would actually occur. And a lot of other models try to calculate the precise chances for any collisions to actually happen. But first of all, it's also important to understand that Apophis is not alone. Apophis is actually one of the many asteroids known as the Aten asteroids, which essentially are defined as asteroids that eventually at some point cross the orbit of planet Earth and orbit near Earth, suggesting that they do have a high chance of collision. We've already discovered over 1,000 of them, and many of them do have a slight chance of collision with planet Earth in the next few hundreds of years. But none of them have a chance that's actually dangerous to us. In other words, none of them have a definitive chance of collision. As a matter of fact, Apophis has the highest chance so far. So in that sense, we are kind of safe for now. Nevertheless, it's still important to understand how we know all of this, and also what we've recently discovered as well. So first of all, we know that the asteroid is going to make the closest approach to Earth around April 13th of 2029. Here's actually what it might look like if you were to look from a distance. As you can see, it passed by Earth without colliding, and its orbit got a little bit deflected as well because of the Earth's gravity. Here's a slightly more interesting simulation that shows you where it's going to pass compared to various satellites orbiting planet Earth. So as you can see, it actually is going to pass not so far from many satellites. It's most likely not going to collide with anything, but depending on how many satellites we have in those orbits, you never really know, although the distance between these satellites is still going to be in hundreds of kilometers. Nevertheless, this really close passage to planet Earth, first of all, is already being investigated as an extremely important opportunity for us to study these near-Earth asteroids and possibly even land here, but also is going to give us a chance to then analyze the next passage, because the next passage might take this asteroid in the vicinity of planet Earth to the extent where it might become more hazardous. And more importantly, this region where it passes right here, and also this region that you see right here, represents the uncertainty of the location of the asteroid when it passes Earth, but also what's known as a gravitational keyhole. A gravitational keyhole represents the location where, if an asteroid passes through, we can then use this keyhole to predict various passages in the future, knowing exactly where the asteroid is going to be. And it just so happens that there is actually a gravitational keyhole that, if the asteroid passes through in 2029, it might increase the chance of collision in the future as well. In other words, these are areas of space, imaginary areas of space, that if the asteroid passes through, the chance for collision suddenly becomes a problem for us. Whereas if it doesn't pass through this keyhole, then we're totally fine. And in some of the recent studies, especially from this year, the scientists also realized that, well, the thing is, the asteroid drifts a lot more than we initially expected. It seems that there is still a chance it might hit one of these gravitational keyholes even in 2029, increasing the chance for a collision in, for example, 2068. And even though this is technically 48 years from when I'm making this video, it still is a bit of a concern for, I guess, the future of the generation that's going to live on planet Earth. And for this reason, several countries like China and Russia have already announced possible missions in 2029, and Russia actually even is thinking about launching some sort of a nuclear ICBM to test it on a nearby asteroid just to see how much all of this gets deflected if a rocket hits it. And not just any rocket, a nuclear rocket. So this would be a pretty extreme but also a pretty interesting test. Now, they're probably not going to be using apophis for this, especially because it's going to pass relatively close to planet Earth, but they did suggest using one of the other Aten asteroids. But why is it that it's now that we're talking about this, and what exactly changed in the last 16 years that we suddenly are concerned again about a possible collision? Well, it's actually the effect known as the Yarkovsky effect, which is in some sense not very difficult to understand. Because of the heating effect from the sun on one side, and because these asteroids usually spin, they often end up having the warmer side, or basically the side that was just warmed up by the sun, now facing the dark cold side. And this warmth produced by this side suddenly starts acting as a kind of a tiny thruster. In other words, it starts emitting photons in this direction, which does produce tiny amounts of thrust based on the idea of photons having a little bit of momentum. At the same time, the sun also kind of pushes the asteroids, so there's also that effect, although that's not the Yarkovsky effect, that's just what's known as the radiation pressure effects from the sun. And so there are two effects kind of acting and in some sense competing with one another, which in the end results in a somewhat dramatic shift of some of these smaller asteroids. Now, for anything that's larger than 1 kilometer in size, so basically for some of the most dangerous asteroids out there, this is not really a big issue unless we're talking about like millions of years. As a matter of fact, approximately 2 decades ago, the most comprehensive study of the Yarkovsky effect was done with this asteroid known as the asteroid Golevka, which is, well, it's actually kind of similar to the one you just saw. And this asteroid is roughly around 1 kilometer in size. But by looking at this asteroid between 1991 and 2003, so basically for about 12 years, and also by studying the predicted location versus the observed location, and using several major observatories including the now famous Arecibo Observatory, which unfortunately is no longer operational, the scientists realized that over the period of 12 years, even this large asteroid drifted by approximately 15 kilometers. And that's quite significant, especially when it comes to measuring something over a period of hundreds and hundreds of years. And the thing about the Yarkovsky effect is that because of the differences in surface, because of the differences in reflectivity, and also just the way that the asteroid spins, it's extremely difficult to predict the total effect that the sun will cause on this asteroid. So there's a bit of a unpredictability to measuring the actual orbits of smaller asteroids. And the smaller the object, the more this effect will influence its orbit. But for objects like Apophis, which is even smaller than the previous asteroid I showed you, this drift can become problematic. As a matter of fact, it can drift by up to about 100 kilometers over a decade. So in that sense, we are still not entirely sure what's going to happen in 2068. But in 2029, when it comes close to planet Earth and will definitely not collide with planet Earth, we're going to have an extremely important chance to study the potential impact with planet Earth, which is still unlikely, but still possible. Now, the most important part about the future investigation is going to be related to trying to investigate the surface with as much detail as possible. By knowing the surface of this object, we might be able to then predict the Yarkovsky effect even better. However, the small issue here when it passes close to planet Earth is that it's very likely that by passing so close to our planet, the gravity of our planet is going to disturb the surface just a little bit. In other words, the tidal forces from our own planet might end up resurface some of the material on the surface and thus change its albedo and its sort of surface features. In other words, the tidal forces of planet Earth might end up sort of restructuring the outer surface of this asteroid, and this will dramatically change the Yarkovsky effect and our ability to predict where the asteroid is going to be in the next few decades. And so in that sense, there's still quite a lot for us to learn. But hypothetically speaking, okay, let's just say it does collide with planet Earth. What would actually happen then? Is this basically game over? Are we going to go the way of the dinosaurs? Well, luckily, not at all. As a matter of fact, the chances for this asteroid to cause any serious damage to any culture around the planet is currently not really that big. And lots of different studies and lots of different simulations have been conducted in the past decade to try to understand what would actually happen if it did collide with planet Earth. Here's a video from one of the studies you can find in the description below that kind of shows you the potential effects if it sort of hits somewhere near the Panama Canal. And as you can see, it does create a relatively large wave. It also does create quite a lot of destruction, but the thing is, most of this destruction will be localized. So if it does by some chance hit a country, then yeah, that country is going to be in trouble. With the total energy released during the impact being about 100 times more than the famous meteor crater in Arizona, but also being about 1,000,000 times weaker than the asteroid that killed the dinosaurs. And in the last few years, there have been a lot of different studies with extremely accurate simulations of a potential collision with apophis-like asteroids. This one here you can find in the description below as well. This is from Los Alamos National Laboratory, essentially showing us that despite extremely dangerous local effects, the overall effect on planet Earth, including climatic changes, are going to be extremely negligent. As a matter of fact, there's going to be most likely no effect on the climate, no effect on other countries or other areas far away from the impact crater. And overall, the explosion itself is going to be equivalent to maybe about 1.2 gigatons of TNT, which in some sense can be compared to about 20 times more than the famous Tsar Bomba, the most powerful nuclear weapon ever detonated on planet Earth. And what's more, in the next year or so, NASA is also planning to launch this beautiful mission known as DART mission that's essentially going to use another asteroid, or actually a binary asteroid, the asteroid right here known as Didymos, and here NASA along with SpaceX are going to be testing the idea of the redirect mission. In other words, here one of the probes is going to hit the moon as hard as it can, while the second probe is going to observe the effects from the collision, calculating the amount by which the asteroid is redirected, because essentially that's our plan for the redirect missions right now. If we collide something with the asteroid with just enough impact and also early enough, it's going to be redirected from the so-called gravitational keyhole by up to 100 kilometers, meaning that it's probably not going to cause any damage in the future. And so in that sense, next year when this mission starts, we're going to talk a little bit more about this and about why this mission is so exciting. But until then, that's kind of all I wanted to mention. Hopefully now you know a little bit more about apophis and why you really shouldn't worry about this, and next time you hear about this on the news, well, maybe just don't worry. We're not going to go the way of the dinosaurs just yet, at least not from an asteroid. Pollution, maybe. Microplastics, maybe. A dinosaur killing asteroid? Very unlikely. Either way, that's all I wanted to mention in this video, and if you enjoyed this, don't forget to subscribe, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something you may have not known before. Also, support this channel on Patreon or by buying the Wonderful Person t-shirt you can find in the description below. I'll see you tomorrow, space out, and as always, bye bye.